Cracks going sideways, but the cracks are curved. In the northern hemisphere, they curve to the left. In the southern hemisphere, the crack curves to the right. And at the equator, it's disturbed. They go all directions. It's the Coriolis effect. How many people know what the Coriolis effect is? A couple? You guys haven't taken that in school yet, have you? Okay. You've seen hurricanes from a space satellite. You notice how in the northern hemisphere they go counterclockwise, in the southern hemisphere they rotate clockwise? That is caused by the Coriolis effect. It's actually caused by the spin of the Earth. In this case, apparently the continents slid east and west of each other. Again, I'm going to show you how and why later on. But they slid east and west of each other, and as they did, the cracks actually followed the Coriolis effect. Here's the catch. The only way Coriolis can work is if it happens at high speed. In other words, today we're told that the continents are dividing from each other at roughly the rate a fingernail grows. Not very fast. According to Dr. Walter T. Brown's model, which I'm going to talk about later, the continents actually moved apart at up to 45 miles per hour. He's actually done the math. That is fast enough for Coriolis to take effect. So what has happened is on the east coast of Canada and the United States, you can actually see the mountains have rotated. And so consequently, within those layers that are making up the mountains, you have all these upright plants. They have also been twisted by the Coriolis effect. It is all evidence of rapid continental division, catastrophe, if you will. Okay, how many people have been to Washington State? One or two? Okay. You may or may not have seen this. When you're heading out there on the interstate, I forget which interstate this is, you see some pretty spectacular sights. This is the Columbia River Gorge, and these are all lavas. In other words, this was all molten rock that poured out onto the surface of the land. It's up to 10,000 feet thick. Huge lava flows. There's actually several out on the west coast. Now here's the catch. They have ball pillows, or pillow lavas all over the place. Guess how pillow lavas are made? Underwater. Who said that? Good man, good man. You passed the test. All right. He's right. Pillow lavas are made underwater. Wait a minute, 10,000 foot thick lava flows? Some 3,000 to 4,000 feet above sea level or more, and they were poured out in vast quantities underwater? We're talking global catastrophe during a global flood. That's what it is. Here's a map of those lava flows alone. There's also the Snake River lava flows, which actually I think are included in those. At any rate, here's my point. We do not see catastrophic lava flows like this forming today, and if we did, it would be a study in catastrophe, not long and slow geologic processes. Anybody recognize what these are? Want to take a guess? Go for it. You got it. Yeah, that's it, exactly. Do you know what the ones that grow from the cave floor are called? Stalagmites, okay? Easy way to remember. Stalactites stick tight to the ceiling. Stalagmites might get to the ceiling. Really easy way to remember, okay? Now, conventional geologists in the past have said that these stalactites take thousands of years to grow. In fact, not far from my home, there is a cave, a touring cave, and when you take a tour in that cave, they tell you the stalactites grow at roughly 1,000 years per centimeter. Now that one there is about 12 centimeters long. That's stalactite. So going by that assumption, How old should that stalactite be? At 1 centimeter for every 1,000 years, 12 centimeters long. 12,000 years. Old, right? Give or take. I mean, again, what's 1,000 years among friends, right? Okay. Here's the catch. I handpicked these stalactites from a hydroelectric dam built in the 1950s. There they are right there. You can even recognize on the far left side this one. Can you spot it? So the evolutionists, or should I say anti-creationists, got very irate. They came back and responded, oh, it's not the same chemically, it's this totally different growing process. Well, actually, we took samples of these stalactites to a lab in Calgary, Alberta. And we had X-ray diffractometry done on them. Big, long technical word for you, don't worry about it. There's the analysis right there. It is calcite, almost completely pure. Now, interestingly, my buddy Vance Nelson, who owns the other Traveling Creation Museum in Canada, he and I collected stalactites from all over North America from man-made structures, bridges, dams, etc. Interestingly, the ones that were the smallest and took the longest to grow were the ones that were most different from caves. The ones that grew the fastest were the ones that were the purest and closest to cave stalactites. So in other words, no, it doesn't take thousands of years. All it takes is one change in one condition, more water. That's all it took. And we demonstrated this chemically, showing they're no different than cave stalactites. The process, the chemistry, everything is exactly the same. Doesn't take thousands or millions of years, and stalactites certainly do not prove that the Earth is millions or billions of years old. What do I got next? Oh, yes, okay. And here's another sample I got with me. I think some of you actually figured out what this was. Did any of you ladies take a look at this already? Or do you have any guesses as to what it is? It's pretty simple. It's wood, yeah, exactly. Okay. See, was that simple or what? Okay, this is a wood fragment. I know it doesn't look like much. This is supposedly a 40-million-year-old wood fragment. I can take my fingernail and run it into it. I can light it on fire. I can build a campfire with it. And in fact, the Inuit peoples up in northern Canada do this all the time. I interviewed a couple of Inuit that came down to my hometown of Pembroke, Ontario, and I said, I've been told there's trees up there. They don't grow up there today, by the way, in case you didn't know that. I said, I heard there's trees and wood all over the place. And she said, yeah, it's all over the place. I said, well, how did it get there? She says, I don't know. But they actually use it for campfires all the time. So this precious 40-million-year-old, they're burning it all over the place. Now here's the thing. This wood fragment came from a place called Axel Heiberg Island. There are polystrate stumps all over the place. You know what the term means now. There's the red star marking Axel Heiberg Island. You can actually take core samples of the tree rings. You can cut it with a saw. You can study the trees as they are sitting there. They are assumed to have been buried, as Joggins was, as they grew. The same as Joggins, the roots are gone. It's very rare to find a stump with roots still attached. Obviously, they didn't grow there. They've been ripped up and transported there by a flood. But here's the thing. This wood tells a very interesting story. These are micrographs of the tree rings. Now, down here on the bottom, these are the tree rings from a redwood tree in British Columbia today in a temperate climate. So at the beginning of the growing season, in the spring, this is a ring, this is a ring, and this is a ring. So if you were to follow it around, the ring goes around in a big circle and then comes back, okay? So in the springtime, the tree grows a fast, soft layer called the early wood. And you can actually see it there, the whiter stuff. Look at the size of the cells, they're huge. They're big, soft celled layers. And then, in preparation for winter, it grows a thick, hard outer layer called the late wood. And you can actually see it, and then it stops for the winter, and then starts growing again in the spring with the early wood. Late wood stops for the winter. Early wood, late wood stops for the winter. You follow me so far, right? Okay. Here is a sample of one of the tree rings from the Axel Heiberg wood. The tree rings are so indistinguishable, they actually had to mark it in the photograph. There's one, there's the other. First thing you'll notice is it's to scale. What took a tree in modern times in a temperate climate, what took a tree 5 years to grow, the Axel Heiberg trees grew in 1 season. This is in the Canadian high Arctic. It's nighttime for half the year. The temperature in the wintertime gets down to 40 below regularly. It is not a wonderful environment for trees, okay? Now, on top of that, you'll notice there is no latewood. These trees, it's as if they did not experience winter. In what a place right now, which is winter for more than half the year. It's not just the winter, but it's also the light. You got to remember, this is on the North Pole. Even during the summer, the land of the midnight sun, even in the summer when the sun comes up, it's still very low on the horizon. And if you have a whole pile of trees, they're going to produce a whole pile of shade. Trees need light. Not just light, but light intensity. These trees had no lack of light, no lack of water, no lack of nutrients, no lack of warmth. The present cannot be the key to the past, because today, that is not the conditions we see in the Arctic Circle. Now, personally, I think those trees were actually floated there by Noah's flood. Now, get a load of this. Lindsay Williams, a couple of years ago, wrote a book called The Energy Non-Crisis. It was actually a conspiracy book. He was a chaplain on board the Alaskan pipeline, the Alaskan oil pipeline. He was actually a chaplain on board the construction crews for that pipeline. And he made mention of a whole pile of fascinating little tidbits of information about the high Arctic. So they're up on Prudhoe Bay, the north slope, the very far north shore of Alaska. This is as Arctic as it gets. But get a load of what he said. There is an interesting point to mention in passing. Though the ground is frozen for 1,900 feet down, wow, that's some serious permafrost. Though the ground is frozen for 1,900 feet down from the surface of Prudhoe Bay, everywhere the oil companies drilled around this area, they discovered an ancient tropical forest. Bizarre. It was in a frozen state, not in petrified state, very much like the wood we find at Axel Heiberg. It's been preserved by freezing, not fossilization. It's between 1,100 and 1,700 feet down. There are palm trees, pine trees, and tropical foliage in great profusion. In fact, they found them lapped all over each other just as though they had fallen in that position. Well, that's kind of weird. It is also interesting to notice that tropical ferns have also been found at the Antarctic, and the evidence from these two areas, considered together, certainly suggests that there has been a dramatic change from a worldwide tropical climate to an Arctic climate within datable times. It is also interesting to remember that the great Arctic explorer Admiral Byrd reported seeing tropical growth in near Arctic regions. The present cannot be the key to the past. We do not have a whole pile of tropical vegetation growing in the North and South Pole right now, do we? And furthermore, we find things like, if I have it with me, that's not it. Aha, that's it. That's not much, I know. Heck, I'll pass it around just so you can get a look at it. This is actually a cast of an armor plate from an animal called a glyptodont. Now, again, we were talking about things being bigger in the past. I'll pass this around, but this armor plate comes from an armadillo, basically. But this armadillo was found in the Antarctic. Now, do we have armadillos around here in Illinois? Why not? Because armadillos hate the cold, right? The cold and armadillos do not get along. Usually the armadillos lose to that one, okay? And you know where armadillos normally live? Down in Texas, you see them quite frequently. They're a small flat creature that lives in the middle of the road. Yeah? Okay. Anyway, I'll pass this around. If you were to see this armadillo and run over it with your car, you would lose. This armadillo was roughly the size and shape of a Volkswagen Beetle. Okay, it's not a small armadillo, okay? But that's one of the armor plates. I'll just pass it around, see whoever sees it. But again, what's an armadillo doing in the Antarctic? It's not like it's going to float there. So the one explanation, the logical explanation, is that that is where it lived, that's where it died, and that's where it was buried. It's the most logical explanation. So as far as I'm concerned, the Arctic and Antarctic were at least a temperate climate in the past, if not a tropical climate. And again, I will come back to that in a later lecture. This, of course, is the Grand Canyon. This is the head of Grand Canyon. It's called Marble Canyon. I bring that up because some have referred to Grand Canyon as what we refer to as a water gap. Now, water gaps are very interesting. There are dozens of them all over the world, perhaps hundreds. I've gotten to study a few of them. Grand Canyon is only one. The thing is, most people don't realize when you go to Grand Canyon, they tell you, oh, this mighty Colorado River carved out the Grand Canyon over millions and millions of years. Has anybody been there to the Grand Canyon? Oh, quite a few. Excellent. Did you hear them say that? Nobody heard them say that. Oh, one did. Okay, good. I'm not a liar. Okay, good. Glad to hear it. They'll tell you the Colorado River carved out the Grand Canyon. Nonsense. You can sort of see it a little bit here in the photo, but the lens distorts it. The Colorado River actually, or the Grand Canyon actually carves through what is known as the Colorado Uplift. It is a giant dome uplift. Now, the thing is, in order for the Colorado River to carve out the Grand Canyon, it would have had to flow uphill for 3,000 feet so it could start cutting into the Grand Canyon. Is that going to happen? Not too likely. Here's the other catch. When you take a look at the Colorado Uplift, if you're at the correct place, you can actually see the Colorado River could have gone around the uplift. The Grand Canyon is what we call a water gap. The water has mysteriously carved its way through a mountain when it could have just gone around. There was no reason for this. So let's take a look at a couple study examples. This is a water gap of the Rattlesnake Mountains in Wyoming. And it's several hundred feet deep. I was told something like 2,000 feet from the top of the mountain to the bottom of the canyon. It's impressive. If you take a close look up it, you can actually see they've dammed it off. There's a hydroelectric dam. There's the access road heading up to the dam. So they've actually dammed it off. We're going to now go on the other side of the mountain, look at the dam from behind, because this is, once again, a classic example of a water gap. There's the mountain, and there's the other side. It has been cut in half by a river going through it. Now the question arises, did the river make the canyon, or did the canyon make the river? I'll let you decide that in a minute. The water has apparently carved through this mountain. Everyone acknowledges that water did it. The thing is, in order to build that dam, we just turned, and we're now looking at the other side of the mountain. They actually had to build a cofferdam on this side in order to build the reservoir because the water could have gone around the mountain. And in the words of a gentleman by the name of Oberlander, wrote an article a few years ago on water gaps, it was just baffling. He said, it's as if some of the water seeks obstacles to transect. It's as if the water took a turn specifically so it carved its way through a mountain. It's as if it looked for things to cut in half. It could have gone the easy way around the mountain, as any water normally would. Why would it do this? What on earth happened? You see, they're attempting to explain it from the uniformitarian perspective again. The present is the key to the past. So how do we explain this? Well, we're going to take a break, and you'll just have to come back in 10 minutes and find out, okay? And we're trying to figure out how on earth did this puny little river cut right through a mountain when all it had to do was take the easy way around. What on earth went on here? This comes back to the uniformitarian principles. The present is the key to the past. You see, it's a false presumption. The river is going through there, and sure, it's eroding the canyon out some more right now. So if the present is the key to the past, the river has always eroded it. But that doesn't work. With the Grand Canyon, the water has to go uphill 3,000 feet. Can't do it. In this case, it'd have to go uphill at least 1,000 feet when all it has to do is go around. Why did it do this? However, within the idea of a global flood, and the present not being the key to the past, it's quite simple. You see, the global flood starts with the water being above the mountains. You see where I'm going with this pretty quick, don't you? It's pretty simple. Within a global flood context, the water starts above the mountains. Now here's the thing. We were talking about these rocks we came up with the question, why were these rocks booking along at 75 miles an hour? That's even on a 2-degree hill slope. It makes no sense. What on earth is going to make the water move at 75 miles an hour? Well, again, this comes back to a global flood. Dr. John Baumgartner's team were performing computer modeling of a global flood. And what they've discovered, serendipitously, this was not in the original plan, this was not part of the original research, they found that the moment the water comes above the continents, it breaks down into Coriolis vortices. In other words, in the northern hemisphere, we had gigantic swirls of water moving counterclockwise, and in the southern hemisphere, we had gigantic swirls of water moving clockwise. These swirls of water were getting into the hundreds of miles an hour in the computer modeling. Well, lo and behold, now we have not only water above the land, we have water moving fast enough on a 2-degree downhill slope to pick up rocks in Idaho, transporting them 700 to 800 kilometers at 60 to 75 miles an hour, somewhere in that range. It all stacks up and makes sense within the context of a global flood. So we have not just water, but high-speed water, which, again, if you remember yesterday, the water at some point obviously went off the land. We're not underwater right now, are we? So at some point, if the water was there, it went off the land. The water is now moving at very fast speeds, and it is now going off the lands. As the scripture says, the mountains rose up out of the flood waters. And so as the mountains rise up underneath the floodwaters, with the floodwaters running off, the water is moving at very fast speed, and we get what we call sheet flow. So basically the water is moving in giant sheets. That makes planation surfaces. If it hits something like a mountain, it can plane it flat, or it will actually become channelized. And what happens here is you have a portion of the mountain or rock that's just a little softer than the rest. This water erodes it and makes a little channel. Some of that water now goes into the channel, so you actually have more flow going through the channel than in the other areas. That erodes the channel more, and so you get channelized erosion, a catastrophic sequence where it starts to cut channels straight through mountains. It cuts around them, through them, etc., until eventually today, after the water is gone, you wind up with what we call a water gap or a canyon that's been cut right through a mountain by the floodwaters, and water now flows through there today as a river or stream. Or you get what we call a wind gap, a canyon or something of the like that's been carved by water, which is dry now today. And that's the term for that, a wind gap. So the question is, did the water make the canyon, or did the canyon make the river? It's the other way around. It's not the river made the canyon made the river. The canyon was there first, the river formed after. So this is all research done by my good friend Michael Ord. Excellent articles. Do read the Creation Research Society quarterly articles on this. Very, very good stuff. Very well done. Now, to use a paleontological term, I've been flogging fossil equians. If you don't know what that means, it means beating a dead horse, okay? We've been beating a dead horse. The present can't be the key to the past. However, the uniformitarians, or present-day geologists, even the neo-catastrophists, the new catastrophists, really only use the present to judge the past when it's convenient. So the mantra that the present is the key to the past only holds true when it works in their favor. For example, okay, coming back again, I'm going to use the model at the Akron Fossils and Science Center to depict the Grand Canyon to show you what I'm going to show you next. Again, this is supposed to have taken hundreds of millions to billions of years to accumulate all this dirt and rock, okay? Now, let's take a quick look at this. A guy by the name of Dr. Derek Ager just loves to hate creationists. Sadly, he's dead now. Wrote an excellent book called The New Catastrophism. Very few books I recommend from anti-creationists, but this is one of them. He's actually trying to argue that catastrophe has played a major role throughout all of Earth's history. Okay, so that's what he's been trying to argue. Excuse me. And so in his book, he made this very interesting comment on the Grand Canyon. He said, even in the Grand Canyon of the Colorado River and the adjacent sections along the Little Colorado River, surely the finest record of geologic history anywhere on Earth, there are huge breaks. I'm going to show you just how huge. For example, here's the Grand Canyon. The Vishnu schist down at the bottom is supposed to be 1.7 billion years old, according to uniformitarian timescales, or deep time scales. The next layer up, the base limestone, is supposed to be 1.2 billion years old. So there's a time gap there of some 500 million years. There's no erosion, and apparently no sediments were left behind during this time. Now, I've done some mathematical and scientific studies. I'm on the road a lot, and my bedroom accumulates roughly 1 millimeter of sediments every year. I know this by research and firsthand experimentation and observation. This is good science. Observability, repeatability, predictability. I can predict when I get home I'm going to have 1 millimeter of dust in my bedroom, okay? So, that's a gap of 500 million years. Remember these numbers, I'm going to come back to it. So that's 500 million years gone. There's no evidence of it. Next up, we have the various Grand Canyon supergroup, supposedly around 740 million years old. Above that, cut across by the Tapete Sandstone, 525 million years old. Again, a huge gap of 215 million years, for which there is no evidence. It's just gone. There's no evidence that that time was ever actually there. Next one up, supposedly 505 million years old, 385 million years old. Again, 120 million years, just gone. Where did it go? Next one up, 340 million years old. Next layer above that, 320 million years old. Another 20 million years, gone, vanished. Remember that number? I'm going to come back to it, okay? We're going to play with that number just a little bit. You'll notice that's the smallest number I've given you so far of missing geologic time. We're going to come back to that number. So, right at the top, you can walk around on this plateau, this surface that's been eroded, supposedly laid down 270 million years ago. Do you not think 270 million years is going to accumulate some dirt? You think there's not going to be some erosion going on? It's easy math, okay? Real easy. We're going to take 20 million years, multiply it by 0.01 inches, you get 200,000 inches over 20 million years. Or 16,666 feet, or 3.15 miles thick of dirt. Where did it go?